Hi everyone, let's talk about salt crystallization. So salt crystallization is a physical weathering process, and I've laid out the steps here, 1, 2, 3, 4. So we can put these steps on a diagram. The first step is that saline water enters cracks and rocks. So let's draw a rock with a crack. Like that. And water can enter through splashing, through rainfall, anything, but the water has to be salty. So you can draw maybe a sea over here, and then when the waves splash, you get water entering. And label this ocean, and then you can draw like a fluid bit of water over here. Then the second step, the water evaporates and increases the salt concentration of the solution. So what happens here is you can draw another arrow of the water going out, evaporating into the sky. And as the concentration increases, when the water has evaporated away, salt crystals begin to form, and they take up a large fixed volume. So as you can see here, the water is quite fluid and it can maneuver through all the cracks, but salt, it doesn't do that. It takes up a fixed volume in space. So it kind of expands like this. You can draw like a big square or something. You can draw multiple if you want. This is usually salt crystallization is really small scale because the salt is really tiny, but you can draw it bigger here. And as you can see here, this expansion, it will exert pressure on the rock, which may cause it to fracture. You can draw arrows as well. And that's it for salt crystallization. You can put the numbers on it. So the water enters the cracks in the rocks. You can draw this arrow as 1. The water evaporates, draw this arrow as 2. The salt crystals form, you can draw this as 3. And then exerts pressure, you can draw the arrows as 4. So that's it. And now we'll move on to favorable conditions. It generally needs a salty environment. And what's the best source of salt in the world that we can or cannot eat? It's the ocean. So generally what you want to do is draw an ocean and have waves splashing on, maybe getting some water into cracks. You also need high temperatures because the water has to evaporate, and the greater the temperature, then the more evaporation happens, and therefore the faster you get crystallization. And you need little precipitation. You may need a little bit of precipitation for the water to get into cracks or something. However, if there's too much rainfall, there's too much water, then your solution, your saline water, it doesn't get a chance to fully evaporate, and it continuously gets diluted with water, and you don't get a crystallization, and you just get water. So therefore, you need a bit of precipitation, but not too much. Otherwise, the rate will decrease with higher precipitation. So that sums it up for salt crystallization. I hope you guys enjoyed, and I'll see you in the next video.